everyone. Today we're going to start lesson 1.3, which is on prime factorization. And we're going to use prime factorization to find the greatest common factor of two whole numbers and the least common multiple of two whole numbers. So first we'll start talking about factors of numbers. And factors of numbers are numbers that will divide into a number evenly without any remainder. So if you look at this first real world link, if you think about the brass section of a marching band having 30 members, and you want to arrange them as many ways as possible, but the rows must be even. So if you look at what I've done here, I know that 2 divides into 30 because 30 is an even number. So I know I can make 2 rows. And I know there would be 15 in each row because 2 times 15 is 30. But if I can make 2 rows of 15, I can make 15 rows of 2. All right? I also know that 3 divides into 30. And I know it easily because I know some really cool rules that help us to figure out divisibility easily without having to actually divide, okay? So I'm going to leave this problem, the real world link, alone right now and let you take a look at it later. But right now I'd like to go over some of those rules that make things super easy for you to figure out divisibility. So I knew that if you go down here and we look at these divisibility rules that I have written out for you, 2 will divide into all even numbers. And remember, even numbers are numbers that end in 0, 2, 4, 6, or 8. Okay? 0, 2, 4, 6, or 8. If I go to the 5 rule, so we did 2. If I go to the 5 rule, that's another one that talks about endings of numbers. If a number ends in 5 or 0, then 5 will divide into that number. Then it's divisible by 5. And if we go to the 10 rule, if a number that ends in 0, if it ends in 0, that means 10 will divide into it. So for the 2, 5, and 10, all you have to do is look at the last digit, and you can decide if that number is divisible by 2, 5, and 10. Okay, let's go to the 3 rule. The 3 rule and the 9 rule are very similar. So with the 3 rule, if you add the digits of the number you're looking at, so for 30, if I go up to 30 and I add the digits 3 and 0, I will get 3, right? And then I just see if 3 divides into 3. Well, of course it does. So that means 3 is a factor of 30, okay? If I look at the 9 rule, same idea. I add the digits of the number. 3 plus 0 is 3. Does 9 divide into 3? No, 9 does not divide into 3 because 9 is larger than 30. So 9 is not a factor of 30. So if you look, there's no possibilities up here in this example that I can't make 9 rows of anything, okay? Now, 6th rule, if I look at the 6th rule right here, if 2 and 3 are both divisible, then 6 will be also. So if you look here, up in my number 30, 2 is a factor of 30, 3 is a factor of 30, so I know 6 will also be a factor of 30, okay? So I love that rule because as soon as I find 2 and 3 are both factors, I know immediately that 6 is a factor as well, okay? Last rule I'm going to go over is this 4 rule right here. If you look at the 4 rule, you're going to make a number off the last 2 digits and see if 4 divides into it. Now, 30 is just a 2-digit number, so I need to know if 4 divides into 30. I know it does not, so I would not list 4s in my number here. Okay, let's do an actual example of using these divisibility rules. So let's say I have the number 1,425. Okay, so 2, 3, 4, 5, 6, 9, and 10. We're going to see if these numbers are divisible. So I'm going to do 2, 5, and 10 right away. So all I do is look at this last digit right here. Is it even? No, so 2 is not a factor. The 5 rule is, does it end in a 5 or a 0? Well, it ends in a 5, so this is definitely a yes. 5 will divide into that number. If I go to the 10 rule, it's supposed to be numbers that end in 0. Does this end in 0? No, it ends in a 5. So 10 does not divide into 1,425. Okay, then let's do the 3 rule. So I'm going to take these digits and I'm going to add them together. So I'm going to take 1 plus 4 plus 2 plus 5. So I'm going to add 4 and 1 and I get 5, and then add another 5, which is 10, and then add a 2. The sum of these is 12. And then I say to myself, does 3 divide into 12? Yes, 3 does divide into 12. So I know 3 is a factor of 1,425. I didn't even have to divide. Okay, now the 6 rule, 2 and 3 must be yeses. 2 and 3 must be factors. 2 is not a factor, so there's no way 6 is going to be a factor. Okay, and then my 9 rule, I added 1, 4, 2, and 5, and I got 12. Does 9 divide into 12? No, it does not. So 9 is a no. And then the 4 rule, remember, is I'm going to take and make a number out of the last 2 digits. So the last 2 digits of 1,425 is 25. Does 4 divide into 25? No, it does not. So 4 is a no. Okay, we'll practice those on the next page. Keep those rules handy as you go through. Okay, so for a second part of lesson 1.3, we're going to again work on practicing those divisibility rules. So we're going to do problems 1 and 2 together, and you can do 3, 4, 5, and 6 on your own. So remember, I want to see if this is divisible by 2, 3, 5, 6, 9, and 10. So I'm going to list those out. And remember, I kind of like to do 2, 5, and 10 all at the same time because they have to do with looking at the last digit. So if I look at this last digit, I have a 0. Does that make it an even number? Yes, it does. So I know 2 divides into all even numbers, so 2 will divide into 780. The 5 rule is that it has to end in 0 or 5. Well, it does. It ends in a 0, so 5 is divisible, 780 is divisible by 5. And lastly, I'm going to check 10. 10's rule is it must end in a 0. It obviously ends in a 0, so 10 is a yes. It's easy to do 2, 5, 10 all at the same time. Then I think we should do 3 and 9 at the same time, because remember they have very similar rules, right? So we're going to take the digits 7, 8, and 0 and add them together. 7 and 8 is 15 plus 0 is still 15. So go to the 3. Does 3 divide into this number 15? Is it divisible by 3? Yes, it is. We get a 5. Remember, when I say divisible, I mean divisible without any remainders. So we know right away that 3 is a factor of 780. Okay? But when I take 15 and try and divide it by 9, I would get a remainder. So 9 is a no. 9 is not a factor of 780. And lastly, we'll do the 6. Remember, I want to check 2 and 3. Are 2 and 3 both divisible, both factors of 780? The answer is yes, so that means that 6 is a yes as well. Okay, all right, let's do one more together. 3,675. 2, 3, 5, 6, 9, 10. Okay, again, let's start with 2, 5, and 10. So I look at the end of the number right here. Is that even? Does it end in 0, 2, 4, 6, or 8? It does not. So that means 2 is a no. It's not an even number, so 2 does not divide into it. The rule for 5s is it has to end in a 5 or a 0. Well, it does, so 5 will divide into 3,675. It is a factor. And finally, 10. The rule for 10s is it has to end in a 0. It does not, so 10 is a no. Okay, let's do the 3 and 9 again, just to see if they are factors of this number. So again, I'm going to go and add the digits. So I have a 3, a 6, a 7, and a 5. Okay, when I add 3, 6, 7, and 5, 3 and 7 is 10, 6 and 5 is 11, I get 21. Okay, so that is the sum of all those numbers. So I ask myself, is 21 divisible by 3? It is. It divides in 7 times. So that means 3 is a factor of 3,675. But when I try to take 21 and divide it by 9, 9 times 2 is 18. I don't even get close to 21, so 9 is a no. And finally, my 6 rule. Well, remember, in order for the 6 rule, 2 and 3 both must be divisible. 3 is, but 2 is not, so 6 is not a factor of that number. Okay? Awesome. Do 3, 4, 5, and 6 yourself. And then we're going to do one more thing, and that is listing the factor pairs of a number. I like to list them in a rainbow style because it gets them in order from least to greatest. The first factor of 18 is always 1. Actually, the first factor of any number is always 1 because 1 divides into every number. And its partner goes over here attached by what I call the rainbow. So 1 times 18 is 18. Now, 2. Well, 18's even, so I know 2 divides in. 2, what's 2's partner? 2 times what is 18? That's 9. Okay, let's use the 3 rule. 1 plus 8 is 9. Does 3 divide into 9? Absolutely. So 3 is a factor. 3 times 6 is 18. 4 does not divide in. 5, it ends in an 8, so we know 5 doesn't divide in. And look, 6 is already there. We knew 6 was going to be a factor because 2 and 3 are both factors. And if 2 and 3 are both factors, 6 is as well. I've covered it all. I've got the combinations, and I've done my rainbow to make sure I have both of the factor pairs. And there we have the list of factor pairs for 18. You're going to do 2 and 3 and then answer question number 4 that goes back to the same band director as the front of it. Okay.